Hi everyone! So today's lesson is on comparative statistics. It's the first lesson of the first unit. And we're going to start by taking a look at this label that I found on the back of a 2% carton of milk, where you guys know when you go to the store, you can see all the different types of milk. You've got whole milk and skim milk, and 2% is usually what I buy. I'm not even sure why. I think it's because it has like a purple top, and my daughter, who's 6, likes purple, so that's what we choose. But I was really confused when I was actually reading the back of this label, and I see where it says that calories from fat 43 and total calories 122, and that's in one serving size. So I'm looking at this outline box in the red here, just because the mathematician in me is looking at that and it's like, that is not 2%. What on earth? That's a lot more. When I calculate it, I get about 35%, a little more than 35%. So where is this 2% milk coming from? Why are they calling it 2% milk? That was my quest. So then I decided, all right, I'm going to look at the grams. So if I come here and I look at the grams, now I'm looking at where it says total fat grams right here. Let me highlight it for you. 4.8 grams. And then a serving size has 244 grams. So that's what I'm looking at here. So when I calculated that, I get closer. I get a little under 2%. I get 0.01967. So you can see that's about 2%. It's 1.967%. Rounded up, it's going to be 2%. So I was like, well, maybe they're calculating total fat, and that's why they're calling it 2% fat. But I also know that some labels go based off this 2,000 calorie diet right here. So when I looked at the calories, I'm not sure why, but first I was like, oh, I'm going to take the 122 out of 2,000. That's not right, because 122 is the serving size. I need to take a look at this 43. So if I ditch this and I look at 43 out of 2,000, then I get a little over 2%. I get about 2.15%. Still rounding to about 2%. So the question I had to ask myself about this label is this 30, where I get this 35% right here, this right here, like, is this misleading? When I'm reading this label, is this misleading? I think it is. I think the majority of people are going to look at this and say 43 out of 122 must be 2% and really not think about it otherwise. And I also thought about, well, what if I was in a different country? What if I was in Haiti or a developing country? Would it be called 2% milk fat then, or would they label it as 35% milk fat because maybe that's more appealing in a different country? Are they choosing this 2% because I'm in America and we tend to be pretty health conscious, and the word fat tends to have a negative connotation, so maybe that's why they're choosing 2%. So that's what launched this lesson in comparative statistics. Sorry, got it off center. All right. And so we're going to talk about how statistics are calculated and how you can really swing them to say what you want them to say. All right, so next we're going to take a look at this chart right here. I'm trying to zoom it in, and for some reason I keep going left and right. Okay, that's going to be close enough. So here you can see this is the murder and non-negligent manslaughters resulting from the September 11th terrorist attacks back in 2001. And we're just going to calculate percentages, just practice calculating some basic percentages from a table before we get started on comparing them. So my first question that I have is, what percent of those killed in the September 11th terrorist attacks were killed in the World Trade Center? So just out of all the deaths, how many were killed in the World Trade Center? What percent? So I need to calculate the total number of people that were killed in the World Trade Center, and I can see it right here. 3,047 people were killed in all locations. And that's going to be, my denominator. That's going to be the total number killed. Then I need to locate, out of that number, how many were killed at the World Trade Center. And I see that right here, this 2,823 number. So when I calculate that percent, 2,823 divided by 3,047, I get 0.926. So approximately 93%, if I'm rounding to the nearest whole percent, were killed in the World Trade Center that day. Let's look at the next question. What percent of those killed in the September 11th terrorist attacks that were killed at the Pentagon were women? So notice here I have this added that were killed in the Pentagon. Now I'm really just isolating it, and I'm just curious about those that were killed at the Pentagon. So let's take a look and let's find in our chart the total that were killed at the Pentagon. I see here the total number is 184 that were killed at the Pentagon. And I want to know what percentage of all of those were women. I'm going to scroll down just a little bit so I can have a little more space. So I can see my denominator is going to be that 184 number. Of those, you can see 108 right here were male, and I need to grab the female. So 71 out of the 184. Let's calculate that really quickly. I get 0.38587. If I'm going to round, I'm going to say about 39% were women. Let's look at the next question. What percent of those killed in the September 11th terrorist attacks were black? So notice I'm back to just those killed at the September 11th terrorist attacks. I have no location that I'm looking at. So I'm back to that total number being my denominator, that 3,000 number again. This 3,047 number. And now I'm looking at, of all of those, how many were listed as black. So I'm right here. I can see that 286 in all locations. So I'm going to be pulling that 3,047 number again. And it was 286. That's what I'm looking at. 286. So let's see what percentage that's going to give me. 286 divided into 3,047. I'm getting 0.0938. So this is going to round to 9% if I'm looking at the nearest whole percent here. So when I'm looking at these percentages, notice how drastically different they are. I've got 93%, 39%, and 9%. So I have a really high percentage, kind of a medium percentage, and then a lower percentage. So think about those numbers, and then think about the questions and how those questions were worded up here. If I wanted to write a sentence or a paragraph where I was trying to make you feel a certain way about these terrorist attacks, I might choose my words so that I could pull one of these percentages, because whenever people are reading, that number is really what sticks with them. And so I just want you to, again, think about how the questions are worded and how we get these percentages. Okay, so in this next slide, what we've got is we've got this table. I'm going to try and zoom in so you can see as much as possible. This is the age, race, Hispanic origin, and marital status of heads of households that experienced identity theft in 2005 and in 2010. So you can see this chart. It has total numbers for me for both of these years. And then it also has the percents in each category, which is really nice. And what I'm wanting to do is I'm wanting to now compare a percentage over time. So I'm saying what is happening from this 2005 year to this 2010 year. And what I'm going to do is I'm going to look primarily at these total percentages. I'm not even going to break it down and look at characteristics yet. I'm just going to look at total percentages. So when I say what percent of homes experienced identity theft in 2005, I'm going to be pulling this 5.5%. And what percent of homes experienced identity theft in 2010? It was 7%. So what we're going to do is we're going to take a look and see the three main ways that we calculate a statistic, which are subtraction, division, and percent change. So in a subtraction statistic, what you're going to do is you are literally just going to take the newest statistic and you're going to subtract the older statistic. So sometimes we even write new minus old when we're taking trying to develop somewhat of a formula here. So I'm just going to do 7% minus 5.5%, which gives me 1.5%. So this would translate into an increase in identity theft by 1.5% from 2005 to 2010. Now let's look at the division statistic. So in my division statistic, what I'm going to do is I'm going to divide the newer statistic by the older statistic. So the most recent. So that gives me that 7% divided by the 5.5%. Notice when I divide my units, my percent cancel out here. And when I divide, I get 1.27273. 1.27273. Well, what does that mean about the increase? What's happening? So this would translate into an increase of identity theft by 27% from 2005 to 2010. Notice this is just changing the perspective, the way that you're thinking about these numbers. In the subtraction statistic, it's kind of like a number line. That's how I would think about this. You think about this number line you've got. How would you get from 5.5 up to 7? You would literally just move 2 or 1.5 units to the right. But what the division is thinking of is it's saying like, okay, if I am the number 5.5, what percent of myself do I need to move 1.5 units to the right? And you need 27% of 5.5. If you guys do an exercise with me and just take 5.5 and multiply by 0.27, you'll get, it's a little less than 1.5 because I rounded this 273, but you get roughly 1.5. It's like 1.49. So that's all this is. It's just a perspective. You're saying you need 27% of 5.5, add that on, and you'll move up to that 7. So when I use the division statistic, I can use this 27% number, which sounds a lot scarier than 1.5 does. Now I want to take a look at percent change. What percent change is doing is it's taking the subtraction statistic and you're dividing by that older statistic. Sometimes we write new minus old all over old. And what the percent change does is it isolates that 27%. That's what I'm going to see. So that I get that 1.5% from my subtraction statistic. I divide by 5.5. And we kind of did this already. We can see here 1.5, that's that change. And I know that 1.5 is 27% of 5.5. My percents cancel. You can see again this translates into an increase by 27% from 2005 to 2010 in homes that are experiencing identity theft. So those are the 3 most common ways that we calculate statistics: subtraction, division, and percent change. And you can see how different they are. So which statistic would you use if you, sorry, let me get this straight for you guys. Which statistic would you use if you were trying to make an argument that identity theft is a growing problem in the United States and everyone should be really, really concerned? Well, if that's my narrative, then I want to use that 27%. It sounds way worse. So that's the division statistic or the percent change statistic, because they translate both to that 27%. But if I was going to say that, look, identity theft is certainly growing, it's a problem, but not that quickly, it's not a huge issue, it's not a major concern, then I'm looking to use this 1.5, the subtraction statistic in this instance. It's not as alarming. So an exercise that I think is fun is to practice writing a sentence, arguing each side as if it were to appear like in a newspaper article or a blog or something legit. And I think it's a fun exercise. So that is comparative statistics in lesson 1.1, and you should be all set and ready to do your problem set 1.1 now.